Bisection Method. The algorithm proceeds in a fashion and is typically stopped when the increment to the left side of the bracket is smaller than some required precision. The overall accuracy obtained is very good, so it is more reliable in comparison to the regular falsy method or the Newton-Raphson method. The process is based on the intermediate value theorem. Applications used to find the real roots of a nonlinear equation, used to estimate the solution of an equation, used in geometric analysis and computer science. It is used for complex problems that need uniform, simple, systematic calculation. Now we have here the formula to solve xm. Xm is equals to the xl plus xu all over 2. To obtain xl and xu, the following conditions must be met. If the function of xl times the function of xm is less than 0, then the xm value will be the new value of xu. If the value of function of xm times the function of xu is less than 0, the value of xm will be the new value of xl. If the function of xl times the function of xm is equals to 0, then the xm is the root. So now we're going to use the bisection method to find the root of the function x squared minus 17. So xu and xl are now set, and to find the function of xl, we need to substitute the function of xl to the function of x. So we have here 4 squared minus 17 is equals to -1. And to find the function of xu, we need to substitute the value of xu to the value of x. So we have 4.5 squared minus 17 is equals to 3.25. Now that we have the values of xl and xu, we need to solve for the value of xm. That will be 4 plus 4.5 divided by 2, 4.25. Get the value of the function of xm. Substitute this value to the x of minus 17 is equals to. Now that we have the values of the function of xm, function of xu, and function of xl, let's try to satisfy the first condition. So if we multiply the function of xl and the function of xm and its product will be less than 0, then the value of xm will be the new xu value. For a second iteration, we have here the value of xu and the value of xl. We need to compute for the new value of xm, and that will be. Now let's get the value of function xm. We have the value of function of xl, function of xu, function of xm, xu, and xl. Let's satisfy the conditions for us to get xu and xl. If we multiply the function of xm and the function of xl, and the product will be less than 0, then our xm value will be our new xu value. And for our second iteration, we have here the new value of xu and still the value of xl. So the value of function xl will be -1 and the function xu will be 0.0156 since our previous value of function of xm is our new xu. So now let's solve for the midpoint. And let's solve for the value of the function of xm. Now let's compute the percentage error in the first iteration and the second iteration. So now we have here this table. Since that in iteration 2 we get 1.54%, that means that the value of our xm is nearer to the value of the root.